Welcome back. This is the second lesson recording for IM1, May 11th, 2021. Okay, now I would like you to state that we've just written statements that says the angles, corresponding angles are congruent. Now I want you to make a statement about corresponding sides. How would you call this, the green side, to be congruent to the green side on the left triangle to the right triangle? Okay, so how would I do that? I would write KF, and this is a side, okay, side of a triangle, so it's a line segment. So it's a line segment, so we would use a line over like so, is congruent to the side on the right hand side triangle is QR, like so. Okay, what about the blue side with blue side here? Okay, so the next side is KC with a line over to say that this is a line segment or the side of the triangle. Is congruent to, on the right hand side triangle is PQ. Congruent to is the equal sign with a squiggle, okay, up and down. And the last yellow side is FC, is congruent to PR with a line over like so. Now let's get back to our slides. So let's do a quick review. What do we say about congruent polygons? We said that the definition of congruent polygons are that two polygons that are congruent if there is a sequence of rigid transformation that carries one onto the other. So if I can transform the bottom figure onto the top one and match exactly, then we say that they are congruent. Okay, and when that happens, the requirements is that all measures are the same, measurements are the same. So that means all corresponding sides have equal length and all corresponding angles have equal length. So this side on the left corresponds to this side on the left on the bottom. They would have equal length, as would all the other corresponding angles and sides. Now let's bring that to a triangle. Okay, so what do? We use tracing paper to replicate the triangle and then transform it to compare the shape, and checked for congruence if all three angles are the same measure, all three side lengths, and all three side lengths are the same. So we did the tracing. But do you really want to be tracing all the time? Well, we're going to level it up. Okay, we're going to make it a little bit more concise so that we don't have to go through the tracing business anymore. We move away from visually trusting our eyes to trusting information given in diagrams. So that means if you have all this measurement, are they congruent or not? Okay, do all the angles match and the side length match? I have 12, 15, 30, and 27. 12, 15, 30, and 27. They do match. Okay, what are the angles? Between 12 and 15, 12 and 15 is 132, and then 47, 47, and then 41, 41, and 140, 140. Okay, so all the side length and angles match, so we say that they are congruent. Okay, and so when we have all the measurements, we can also come to that conclusion. And if I rotated this original figure to the clockwise, I could map it onto that exactly and then translate it. Okay, so they are congruent, which means that all corresponding side lengths are the same and that all corresponding angle measures are the same. Now I want you to tell me in private chat. Okay, so when you see these two polygons, okay, two quadrilaterals or two shapes with four sides, are they congruent or not? No, because we don't know about the angle measures. They certainly look congruent. They look about the same length and same shape and everything else. But do you think your eyes are very good enough to be able to tell that this was 90 degrees, but this actually was 89 degrees, 91 degrees, 89 degrees, and 91 degrees? Even though the side length were the same, you can still have the angles that are different. So in that case, they are not congruent. In fact, this is what we call rhombus. Okay, and if you can think of, this is a square and this is a rhombus, and just because two lengths are the same does not mean that they are going to be congruent. Okay, so it needs to be both angles and side length that are congruent. Alright, so then what about this? Are they congruent or not? Are the two figures congruent or not? 63, 75, and 42. 9, 12, 13. 9, 12, 13. They are congruent. It's as if the right figure was rotated anti-clockwise, counterclockwise, to be mapped onto that. Okay, so we can certainly rely on measurements to tell us that they are exactly the same figure. Okay, but is that the only way? No, we're going to level up even one more step. We're going to use notation. Okay, remember, if you have the same number of arc, means that they are these two, angle R and angle F, are exactly the same in measure. Angle S and angle G are exactly the same in measure because they both have two arcs, and angle T and angle H are exactly the same in measure because they both have one arc. Okay, and you have one line segment with one notch, another segment with one notch. That means side length ST is exactly the same in length as HG. So now we don't even have to have all the measurements, right? We can use this notation using the notches and arcs to indicate which are the same measure, which are the same length, or which are different. In this case, I know that this side and this side length are different just because we have one notch here and three notch here. Okay, so in this case, are they congruent? Yes, they are, because you have 1, 2, 3 tick marks, and then one tick mark between one arc mark between one tick mark and three tick marks. So one tick mark and three tick marks, in between those you have one arc, and then two arc here between one notch and two notch, and then three tick marks between the last side. Okay, so it is congruent. And so we're moving from having numbers to go tell us that they are congruent, or the measurements to tell us they are congruent, now to using notations and symbols. So two triangles are congruent because when each of the angle measures and side length are exactly the same or congruent. But now we can move on to using notations and symbols here like this, and we can come up with congruence statement. This is what we call congruence statement, triangle DOG. Okay, so we're calling the left triangle, naming the left triangle as triangle DOG using the vertices of the triangle, is congruent to, remember the symbol that we saw, this is a congruent symbol, congruent to triangle CAT. And we're going to talk about the order more in the next slide. Okay, so here the order matters. Okay, so notice that D, the vertex D, corresponds to vertex C, because we know that it has one arc here and one arc here. So D and C corresponds to each other. So, and they are the first letters on both the triangles. Okay, and let's see, the two arc is where O in the left triangle and A on the right triangle. That means O and A has to be in the same position. O on the left triangle is in the middle, and A on the right triangle is also in the middle. They need to match up. And then G is the last letter here, and T is also the last letter because they're the ones with the 3 arc. Okay, so it's easiest to match up the vertices without getting confused. Okay, so the order does not matter, but the position matter. D needs to match up with C because they are the corresponding vertices or the corners, and A matches with O matches with A, and G matches with T, and so the order does matter. And so position of the letter indicates the matching part. And okay, so please take this down. Okay, so let's look at another example. This time we have triangle XWV is congruent to triangle BCV. This is what we are given. Okay, now we need to mark the angles and sides of each pair of triangles to indicate that they are congruent. Okay, so that means let's start with X. X and B are the first letters on each of the triangle. X and B. Find your vertex X and B. They're going to have the same number of arcs to communicate that these two are the same corresponding parts. Just because they look like they could be a reflection, you cannot go with what it looks like. You might think that W corresponds to B and X corresponds to C. But no, you need to go from what is given, what the information we are taught is that XWV, triangle XWV, is congruent to triangle BCV. Okay, so then what is the next letter? Next letter is W matches with C. W matches with C. That means W, the angle measure of W would have 2 arcs here, and C would have 2 arcs there. Okay, and then finally I can go with V matches with V. V matches with V. So V from the left triangle matches with the vertex V from the right triangle. So that's how they match up. Okay, now what about the sides? Okay, the easiest way, if I say side V, that's ambiguous, isn't it? Because side V could be talking about this side or this side. That's why you need to be using 2 letters. Okay, but as far as identifying the sides, what you can do is you can go with 2 of the letters. Okay, so XW, the side XW, where is side XW? Is this one. Okay, XW is this one. Is going to correspond to, what are the first 2 letters of the right triangle? Is BC. BC is this one. So I know that they correspond. So if that is the case, they're going to have the same number of notches. So I'm going to put 1 and 1 there. Okay. All right. So then next, I am going to use these 2. Okay. W and V. W and V is this side here. Okay. And that corresponds to last 2 letters is the CV. CV is this one. Okay. No, it's not the top one. It's the bottom one. So that means I am going to put maybe 2 arcs there and 2 arcs there, or 2 notches, to say that these 2 are the parts, the length that are corresponding. And then lastly, the orange, let's say, is the V with X. V with X and B with C. Okay, V with X, V with X is this one. That corresponds to with this side, and so I am going to put 3 notches to say these are the corresponding sides. Okay, now list the matching parts of the congruent triangle. I can do what we did here. So L matches with B, so L matches with B, and M matches with C, and K matches with D.